feel free to pause the video if you'd like some more time to reflect and think about the process, the procedure, and the motivations for each step. Okay, for this one, let's let u be equal to the natural logarithm of x. The rest of the expression will be dv. So that's this. For expressing it using negative exponents, since negative exponents are a little bit easier to manipulate, we get this. So du is equal to 1 over x dx. And v over here, using the power rule, so negative 5 plus 1 is negative 4. So that's x raised to negative 4 over negative 4. So that's negative 1/4. So x raised to negative 4, we have a negative exponent, so it converts to 1 over x raised to 4. Or essentially, this is negative 1 over 4 x raised to 4. So we're playing around with laws of exponents. Therefore, applying integration by parts, what do we obtain? Color coding, u is ln x, b is negative 1 over 4x raised to 4. Transfer this a little bit to the left. Integral sign b, color coding du, algebraic simplification. So we get this. For this we get this. So negative. That's why we have addition over here. So we try to factor out the 1/4 and convert 1 over x raised to 5 to one expression with negative exponents. With a negative exponent, that will be x raised to negative 5. So using the power rule, negative 5 plus 1 will be equal to negative 4. So the integral of x raised to negative 5 will be x raised to negative 4 over negative 4 plus c, the constant of integration. And so our final answer will be this. It will be a negative 1 over 16. This x raised to negative 4 becomes 1 over x raised to 4. They're equivalent. So it goes here to the denominator, but with a positive exponent this time, plus c. So this one involves some manipulation via the laws of exponents. So again, the final answer will be negative ln x over 4x raised to 4 minus 1 over 16x raised to 4 plus the constant of integration. Okay, let us proceed to some more examples. This time, let's try something that's somewhat more difficult compared to the previous integrals that we have solved. Let's clear everything in preparation for this. Okay, let us try to take the integral of this one. Let this be, let's use blue for u, consistent with our previous color codings. So the rest of the expression becomes dv. The integral of e raised to 3x, to counteract or counterbalance the 3x, we multiply by 1/3. And then since we are dealing with Euler's number, it's the same thing. Okay. Now that we have this, we are now ready to perform integration by parts. So, could we recall what integration by parts, what the formula for integration by parts is? Again, it's a cute little tongue twister. The integral of UdV is equal to UV minus the integral of BdU. Color coding. U is x squared. V is 1/3 e raised to 3x. Again, we have 1/3 e raised to 3x. And du now is 2x dx. Simplification. What do we get here? By simplifying, we get 1/3 x squared multiplied by e raised to 3x minus 2/3 e raised to 3x x dx. We factor out the 2/3 and we will write this in a more recognizable form just to be more consistent with this one. X multiplied by e raised to 3x dx. Now, it seems that we're stuck. Conventionally or ordinarily, we don't really know how to do this integral over here. But wait a minute. The key insight, the eureka moment, is that this is actually solvable using integration by parts. So in essence, we are applying integration by parts twice to solve this problem. First, in order to arrive here, and second, in order to solve this. So let's go. So we solve this using integration by parts. So what would be our u? Our u would be x, kinda similar to what we're doing over here. And the rest of our expression becomes dv. So du will be equal to dx in this particular case. And v will be equal to same thing as before, 1/3 e raised to 3x. Integration by parts. Color coding. Color coding. Du is dx. Algebraic simplification. X over. Let's just have this as 1/3 x e raised to 3x so that things are a little bit less messier. Okay. In any case, let's continue. This one now is equal to 1/3 dx. Let's continue. 1/3. Again, we multiply by 1/3 to offset the x over here. And constant of integration. So we have our answer to this one. But we have to integrate it to this one as well. So it can be a little bit confusing. The result can be a little bit unwieldy. So we have to be organized with how we write our solution. So we slow down in order to review what's happening here. Okay, it seems and we hope that we have not committed any serious arithmetic error. So let's make things smaller and let's combine the results together. Okay, let's just remove this divider over here. going to our original. So we are actually referencing this one. That's 1/3 x squared e raised to 3x minus 2/3 times this thing over here. So 1/3 x raised to 3x minus 1/9 e raised to 3x plus c. So as not to squeeze our writing, let's a little bit to the left. And this also a little bit to the left. Okay. Oops. Let's proceed. Let's continue. So 1/3 x squared e raised to 3x minus distributive property 2/9 x multiplied by e raised to 3x distributive property minus 2 over 27 e raised to 3x plus c. And this is our final answer for this problem. Again, just to recap, we did integration by parts twice. So this is the first instance of integration by parts. But to solve this integral, we have to perform integration by parts again. After we have solved for this integral, we plug it in here, giving us this side. So the final answer would be 1/3 multiplied by x squared times e raised to 3x minus 2/9 x e raised to 3x minus 2. Rather, this one is plus since negative and negative. Oops. This just goes to show that we must be very, very careful with the arithmetic. Plus negative times negative is positive plus 2 over 27 e raised to 3x plus the constant of integration. So it's quite long, though the steps are systematic. And once again, it's very important for us to be organized with how we present our solutions. Okay, let's dive into some more examples. Let's say we want to integrate this. Again, these examples are taken from the mathematics department's website of the University of California, Davis. Which one is our U? Which one is our V? It's a matter of trial and error, intuition, and loads of practice. But we let this be equal to U, and the rest will be equal to V. So U is equal to ln 5x, natural logarithm of 5x, and dv would be equal to x cubed dx. So that would mean that du will be equal to, using the chain rule, we are dealing with 1 over 5x multiplied by 5 dx, which would mean that this is just equal to 1 over x dx. And then for this one, we integrate x cubed using the power rule, we get x raised to 4 over 4. We proceed to the usual integration by parts. Tongue twister. Integral of u dv is equal to ub minus the integral of b du. U is equal to ln 5x. V is equal to x raised to 4 over 4. Then we perform a subtraction, color coding in order to make the solution clearer and more visual. Du is equal to 1 over x dx. We perform algebraic simplification. This is equal to x raised to 4 ln 5x all over 4 minus the integral. Cancel. We'll just be left with x cubed over 4 dx. X raised to 4, natural logarithm of 5x over 4 minus, put 1/4 over here, x cubed dx, we factored out 1/4. We use the power rule over here, copy the minuend for the subtrahend, we will get 1/4, and this will be multiplied by 3 plus 1 is 4, plus the constant of integration. Simplifying things, we get this. Plus C. So this completes this problem on the board. Okay, proceeding to our next example. So we're kind of doing a marathon of several examples to get our hands dirty, to get our minds working, and to get ourselves more accustomed to the wonders of integration by parts. So it's really important to practice, practice, and practice. The concept itself may seem fairly easy, but when we already delve into problems, things can really get rather tricky. So it's important to practice and practice. Okay, which one is U? Which one is DV? Let U be this one. This would mean that the remaining portion will be DV. So actually that's dx. Okay. So we take the derivative of this one. Again, we have to use the chain rule. So lessons from CS Math 1 are crucial, they're critical, they're fundamental to surviving ST Math. Chain rule. So we use the power rule here first and then multiply with the derivative of the inner, that's ln x. So this is equal to 2 ln x multiplied by the derivative of the inner, that's 1 over x. Writing things, we get 2 over x ln x. All right. Okay, seems legit. For this one, it's simply equal to x. dv equals dx implies that v is equal to x. Integration by parts. So let's try to make our writings smaller. Integration by parts, a cute tongue twister. That's the integral of u dv is equal to uv minus the integral of dvu. U is the square of ln x. V is equal to x. Sorry, this is v du. Uh-oh. v du. So this is x, and du, color coding, is 2 over x ln x. This is a pleasant surprise. We seem to have forgotten dx here as well. Okay. X multiplied by the square of the natural logarithm minus, these things will cancel out. We'll just get 2 ln x dx over here. We can factor out the 2. And we get this. Now, this one's a bit of a doozy. What is the integral of ln x? The derivative is easy. It's just 1 over x. But what is the integral of the natural logarithm? As you might have surmised, or as you might have suspected, it is time for us to once again use integration by parts. Quite a handy technique. So let's perform integration by parts to get the integral of ln x. Quite interesting, since integration by parts is necessary to get the square of the natural logarithm. It's also necessary to get the integral of the natural logarithm itself. Okay. This will serve as our u. This will serve as our dv. So it's quite analogous to this one. Doing the usual math, 1 over x dx, v equals x. Integration by parts, cute tongue twister. U is ln x, color coding. V is x, v is x. Du, oops. Du is 1 over x dx. X ln x. That's x. So 2x ln x minus x plus c. So we have to plug it in there. So we make our handwriting smaller again so that we have some space. It would be nice for Zoom to have an infinite whiteboard similar to Microsoft Whiteboard. All right, so going back, we have already established that this is equal to this, minus 2 times the integral of the natural logarithm. And we have further established that the integral of the natural logarithm is equal to this, x ln x minus x. Just add the constant integration here. It doesn't really matter if you put it here, it's okay. If you put it outside, it's okay. After all, it's just an arbitrary constant. So it doesn't matter. 2c, c, same banana. X squared minus distributive property 2x ln x. We won't fall to the same trap again. Negative times negative is positive. Positive 2x and plus c. Can we simplify anything? Okay, no, this one is the final form. So x times the square of ln x minus 2x ln x plus 2x plus c. And this completes the solution. Once again, we perform integration by parts twice. First time, second time to get the final answer. This also wraps up our discussion of this rather advanced calculus technique. On behalf of PTS, I would like to thank everyone who watched this video, as well as the Salle Computer Society, for inviting us to be part of this initiative. Thank you very much and have a good day.